All right, let's start talking our way through this bell work. First thing I want to do is go through and identify the A, the H, and the K values. What is my A value? It's 1. It's found right here, but since I don't see a number there, it's a 1. That's the only one that if I don't see it, it's a 1. What if I don't see H or I don't see K? What would those be?
0.
Those would be 0. A being 1. If I multiply something by 1, does it change? No. This A value is not going to change anything about my graph, so I'm not going to write anything down for a transformation there. Let's do K next. What is my K value? -3. Here's my K. Will that affect my graph? Yes. What will that do to my graph? It's going to make it go up or down. So this value right here, this specific K value is going to take it which way? Down how far? Down 3. When we're using words like left, right, up, down, stretch, compress, reflect, we're just going to name the values. We're not going to put negatives on them. So in your descriptions, we'll never have negative numbers, but we know that down means in the negative direction. All right, and then the tricky one. Why do I call it the tricky one? Yes, we have to do the opposite because we got to take it and set it equal to 0. This right here is the opposite of H, which means H is actually what? Will that affect my graph?
Yes. You need to go left 2 times.
Yes, we're going to go left 2 times. What we've written in words, when we make our graph, we should see happen on the graph. We'll get to that in a minute. I do want to name the vertex next. The vertex is always going to be HK. So what would the ordered pair for this vertex be? -2, -3, because it's my H first and then my K. Axis of symmetry is wrong if you don't have what at the beginning? X equals. This is the equation of a line. You have to have the x equals part. The axis of symmetry cuts my parabola exactly in half, which means it has to go through what? Has to go through the x-axis and through the -2, through my vertex. And it's going to go through that x part of the vertex since it's cutting it in half. So I'm looking right here for this number. It's always going to be x equals whatever my h value is. All right, let's do domain. And I'm going to hold off on range until after we have our graph, because I want to be able to look at that with you. I feel like the range there's still some confusion on. And so I want to be able to look at the graph and really talk about where this is coming from and how I can know for sure. But the domain is the same for all my parabolas, no matter whether it's the parent or a transformation. Does anybody happen to remember what that is? Yes, ma'am. Yes. -∞, comma, infinity. What this means, my domain is talking to me about the things I am allowed to use as input, the things I'm allowed to use for x. -∞ means that there's no negative number I could possibly think of that I'm not allowed to use. I can use any negative number I want to. Positive infinity means the same thing, but about positive numbers. So any number that you could put into your calculator, you can use as input here. Positive, negative, decimal, fraction, square root, does not matter. Let's go and make our graph, and then we'll talk about the range. So I'm going to make a table like we had yesterday in your book. I'm going to do the parent first. The parent function, yes. The rule for our parent function is y equals x squared. I pick my 5 favorite x's, easy to work with, small numbers that I can do some mental math with them. I always pick the same 5, -2, -1, 0, 1, and 2. We choose the x's. We choose the input. We find the output. I use this function rule right here to figure out what my y's should be. Don't just memorize the parent table, because we're going to work with a lot of different functions this semester, and each one has its own parent. You need to know how we're finding these numbers. So I'm going to take each of these x's, I'm going to put it in the place of x here, and then do what to it? Square it. So negative 2 squared, or negative 2 times itself? 4. Negative 1 squared? 1. And then 0. And then what do you notice happens after the 0?
The numbers repeat.
The numbers repeat, because I take 1 and square it, and then I take positive 2 and square it. I'm going to go ahead and put those on my graph, because I want to compare the parent to the transformation to see if it really did what we said in words. So I'm going to put my points on here. Remember, you have a graph at the bottom of page 44 that you are welcome to use. All right. Now we're going to get into this transformation. The x-axis goes which way? Left and right or up and down?
Left and right.
Left and right. Which piece of the transformation affects things going left and right?
The x. Wait.
Sorry, between AH and K, which thing affects H? So since the x-axis goes left and right and H changes things going left and right, I'm going to take my H value and I'm going to add it to each of my x's so that I can find my new x's. So I'm going to take negative 2 and add it to each one of these. When I add a negative number, that's the same thing as subtracting it. Negative 2 plus another negative 2 is going to give me what?
Positive 4. Wait, you said negative 6.
Negative 2 plus another negative 2.
Oh,
Negative 4. Negative 2 plus negative 1. Negative 3. And you're welcome to pull your calculator out and do this, especially if adding and subtracting negatives is something that you've kind of struggled with. Then I get negative 2, negative 1, and down at the bottom I have 0. That's the only thing that affects my x's, is H. The A and the K will both make changes in my y values. With A, we multiply, and with K, we're going to add or subtract. According to order of operations, which one comes first, adding and subtracting or multiplying? Multiplying. So we have to do the A first. What was our A value again? 1. When I multiply these things by 1, none of them will change. Then we add or subtract our K. What was our K value?
Oh, your K value negative 3.
Negative 3, so I'm going to subtract 3 from each of these. And after I do those operations,
You get 1, negative 2, oh, wait, no, negative 3, negative 2, and negative, what is it, 3, or no, negative 1.
very close. I think you got confused right at the end. That's okay. We have 4 minus 3. I get a positive 1 here. 1 minus 3 gives me negative 2, which is exactly what you said. 0 minus 3 is negative 3. And after that middle point, I'm going to see my y values repeat. So it's going to go back to a negative 2 and then a positive 1. These points right here are what I'm going to graph to get my transformed function. So negative 4, 1, right here. Negative 3, negative 2. Negative 2, negative 3. Negative 1, negative 2, and 0, 1. And then I trace it in. In words, what did we say was going to happen here? What did we say in words for our transformation? We said it was going up or down, left or right?
We go left 2 and down 3.
Left 2 and down 3. When I look at the parent and I see how this would have to move to become that one, did it move to the left? Is the red one to the left of the parent? Yep. Is it down lower than the parent? On my graph, I should see happening what we said in words was going to happen. Last thing we need to talk about is the range. So here's why I waited on this. When we talk about the range, the first thing that I'm going to see in the range is the minimum. And the second piece is always going to be the maximum. This is talking about output, y's. So when I'm looking at a graph, I'm looking up and down. I don't care about left and right at all. Left and right is my domain. This point right down here, that's my vertex, right? Is that vertex a highest or a lowest point? Lowest. So it's a minimum. The vertex is a minimum. So I'm going to be looking at this for the minimum value. Does this parabola have a highest point? Infinity. What makes you say that? You're right. Tell me why. Yeah, the arrows means it goes up forever. So when I go to write my range, I'm looking at the vertex for the lowest point, because that's the lowest point here. What is that y value on my vertex? -3. I'm going to use a square bracket there, like this. It's the lowest point, and we actually have a point there. If it's possible to put a point there, we're going to use a square bracket. We said it goes up forever, so could you point to where the highest place is here? No, so we're going to use infinity to explain that it goes on forever. If I gave you a graph, a big poster-sized graph, could you put a point on infinity? Then I have to use a parenthesis there. If I can't actually put it on the graph, no matter how big my graph is, I have to use a parenthesis. So far, so good? All right.
Question.
Yes.
Why do you use -3 instead of -2?
Good question. So my domain is telling me all the things that I am allowed to use for x. It's telling me about my input. The range is very specifically telling me about all the things y can be. So all the possible output. That's why we use the -3 and not the -2. That's a great question. Does anybody have any other questions about the bell work for me? All right, we're going to keep practicing with graphing today. We're going to look at a really hard one first and do it together. And then I'm going to set you guys loose on one on your own. And you're going to do it start to finish on your own and see how you're doing with it. Okay? All right, so on page 60, we're going to be down at the bottom. We did the top graph yesterday. Down at the bottom of page 60. This is problem number 7. I want to start off, before we do any AH or K stuff, I want you guys to do the table for the parent, and I want you to graph the parent. This is exactly the same as the blue graph that I made on the bell work. So I want you to do the table for the parent, and I want you to graph the parent. give you guys a couple minutes to do that on your own. You need to come up with the x values and use that to find the y values. Same as the parent in the problem before it, same as the problem from the bell work. Parent function for parabolas will not change. All right, let's check to see how we're doing with this. What are the x's that we're going to pick? Because we get to choose those. Yes. My 5 favorite x's, -2, -1, 0, 1, and 2. To figure out the y's, I go to the function rule itself. My parent function rule says we're going to take our x's and we're going to square them. So I'm taking each of these numbers and I'm going to multiply it by itself to get these outputs. So if I take -2 and square it, what do I get? +4. What about if I take -1 and square it? 0 and square it? 1 and square it? And 4 again. So we're going to go put that on our graph. I'm hoping that this is just a check, because you guys should have this already. Sometimes I know we need some extra assistance, though, and that's okay. I want you guys to know how to recreate these on your own. Let's go ahead and do the domain and range for the parent. The domain is the same no matter what kind of parabola we're looking at. That will always, always, always be what? Yep, -infinity to +infinity. Absolutely correct. The range for my parent function. When I'm talking about range, it's always going to be the lowest point, my minimum first, followed by the maximum point, the highest point. What is the lowest this parabola ever goes? 0. Can you actually put a point on 0? So we use a bracket there. It's a number that I can find on my graph. What's the highest it ever goes? Infinity. It has arrows on the end. It goes on forever. And I have to use a parenthesis there because I can't ever find infinity on a graph. All right, now we're going to go look at our transformation up here. So I'm looking at this guy at the top. We got a lot going on there. Let's start at the back and work our way forward. What is my -3? Who is that? Yep. That's my k. K is always the one that's at the very end. It's going to be added or subtracted. It will never be inside parentheses. So my k value is -3. I'm going to write that down here. Will that affect my graph? Yes. What will it do to it? It's going to make it go down 3. What is my h value? -3, because right here I have the opposite of h, so it's going to go left 3. Good job. And I left a for the end. Yes, -1/3 for my a value. There's a lot happening there with a -1/3. There's 2 things that I look at. We got a decimal, because if I put 1/3 in my calculator, what do I get back? 0.3 repeating. And you're welcome to pop it in your calculator and always check. But 1/3 in my calculator starts with a 0, and then it's a decimal. So this is going to be a compression or a stretch? Compression. Anytime I pop it in my calculator, if it starts with a 0 in my calculator, it's going to compress it. So this will be vertically compressed. By 1/3. I'm not putting the negative there. I'm only putting the 1/3. Remember, in my descriptions, I never, ever, ever write negative numbers. I use directional words to explain that. Like we had down and left Compressing something doesn't have to be negative. With my a value, the negative is doing a very special job. What is the negative going to do to my graph? The fact that a is a negative. It's going to reflect it over the x-axis. And again, this is because a is negative. When we say it's going to be vertically compressed by 1/3, I'm thinking about what happens if I have a big squishy ball like a yoga ball. If I vertically compress it by sitting on it, it's going to go down, but that air has to go somewhere, so it's going to look like it gets wider. So when I say vertically compressed by 1/3, I know on my graph that it looks wider. So that's what I'm going to be looking for when I actually get this fully graphed. All right, tell me which pieces of A, H, and K affect the x values? H. We're going to add H, so I'm going to add -3 to each of these things. Remember, adding a negative number is the same thing as subtracting it. That's absolutely correct. We're going to get -5, -4, -3, -2, and -1. Those are the only, those are the only things that affect my x's, is just the h. Then I want to move over so that I can find my new y values. Multiply by a. So what are we multiplying by?
1/3.
-1/3. Oh, that's going to get messy. That's okay, though. You are going to want your calculator for this part. So if you don't already have a calculator out, or you don't already have your calculator up on your phone, please go ahead and do that right now. Okay, so we're going to multiply by a first, and then do I need to do anything else? We're going to add our k value. What's our k value? -3. So we're going to subtract 3 from each of these things. All right. Here's where I need your calculators. We're going to take 4. We're going to multiply it by -1/3. When we multiply by -1/3, that's the same thing in your calculator as dividing it by -3. So you can take your calculator, you do 4 divided by -3, and then you take that answer and you subtract 3. It's going to run off your screen, that's okay. What do you get when you do 4 divided by -3 and then -3? Yeah. You should get -4.3 repeating. It's okay for me to have decimals over here because I'm just using these numbers to be able to graph it. And I know where -4 is on my graph. -4 is right here. So -4.3 is going to be just a little bit below that. So I'm going to go just below the -4. So far, so good? All right. Now I need to do the exact same thing here with this next y value. So I'm going to do 1 divided by -3, because that's the same thing as multiplying by -1/3. So 1 divided by -3, and then I take that answer, and I -3. -3.3 repeating. And I know where -3 is on my graph, so this is going to be just a little bit below that. So I go to -4, -3. It's going to be just below the -3 there. What's 0 times anything?
0.
So this is going to become a 0. 0 minus 3 is -3. Finally, a nice whole number point. So -3, -3. I've got a point right there. And then I start doing the exact same things in my calculator, right? I already did this calculation, so I already know what it's going to come out to give me. What will this one give me? Yep, -3.3 repeating. So again, that'll be just under the -3. And what about this last y value? -4.3 repeating. So just underneath the -4, like this. And then I sketch through those points. Good work, guys. All right, the last thing we need to talk about with this is domain and range. But before I put anything for domain and range, I want to check that my graph really did what I said with words. We said it was going to reflect over the x-axis. Did it do that? How do I know from the picture whether or not it did that? It's on the opposite side. It's upside down. It opens down. So yes, it really did reflect. Does it look wider than the blue one? Yeah. It looks much wider than my blue one. So it has been vertically compressed. Is it to the left of the blue one?
Yes.
And is it down compared to the blue one? Cool. So I'm pretty sure that my words and my graph match each other. For my domain, that one's easy. This is always the same for all my parabolas. So my domain is going to be -infinity to +infinity. All of my parabolas have the same domain because I'm allowed to use whatever I want to for an input for an x value. On my range, remember we start with the lowest point, the minimum, and then we put our maximum after that. Here's the vertex on this parabola. Is that vertex a maximum or a minimum? Maximum. This is a highest point. I don't start the range with the highest point. I start it with the lowest point. What is the lowest point on this parabola? -infinity. It has arrows on the end, so it goes down forever. So I have -infinity for my minimum. Is it possible to graph a point on -infinity? No. So I have a parenthesis there. Now I want the maximum, and this is always telling me about the y values. So what is the biggest y value? -3. We put a bracket because why? Yeah, I can actually put a point there. We did. If it's possible to graph it, we're going to use a square bracket. All right. It's going to be really helpful for this next problem if you have your book open so that you can see this page and page 61 at the same time. I want you guys to do problem number 8 up at the top of page 61. Whole thing start to finish on your own. I'll put my answer for it up here in a minute after you guys have had the opportunity to work on it. You want to look at what you did on this problem and try to repeat the process. All right. There's the correct answer up on the board. If you're interested in retaking your test, or if you have questions for me, please let me know as I come around to pick those out. Oh, you're right, sorry. Should be up to, my bad. should be up to, I even put it correctly there, but I wrote the wrong thing up at the top. Thank you guys for catching my mistake. Nice catch there. Please remember, do not leave the room with a test. If you're interested in taking it, please let me know. I'm more than happy to have anybody come in and work with